Hey guys, welcome back to section 4.5. I'm on page 392, so let's just get going. So we've got just one application here that I want to just touch on. So here's the problem. Lisa wants to rent a booth this weekend at a craft show to sell necklaces that she makes. The booth costs $300 to rent, and each necklace costs her $5 to make. Write a function to model this situation. So this is what's known as our cost function. So in this case, so it's a $300 flat cost, and then the other cost she has is dependent on how many necklaces she actually makes. So that 300, that's one part of this, but how do I model something that is just dependent on the number of necklaces that she makes? Well, that would be 5 per necklace, so that would really be like something like 5n. And maybe I should actually call this, well, we'll just call this y equals 300 plus 5n, where n is the number of necklaces. So here's the first part of this problem. Next it says, she plans to sell the necklaces for $20 each. Write a function that would represent this. So how would I represent then her getting $20 per necklace? Well, that would then just be, it's again dependent on the number of necklaces that she sells. So it would be y equals 20n. So notice here, these are, now this is really a system. And so we can once again use a graph to model this, although 300 is kind of a larger number, so I actually just kind of graphed it for you, just so you can kind of see this. So you can still use, systems to model out equations like this, and then your solution would still be found here. So what is this point? This is the point. This looks like what? 20, looks like 400. So there's the point, and we're asking for what is the break-even point. So what does it mean to break even? Well, this function here, this one, this is the y equals 20n. And this one here, this is y equals 300 plus 5n. This break-even point is talking about the point where she doesn't lose any money. Right? This booth costs quite a bit to rent, $300. So this point, 2400, is describing what she needs to actually do so that she won't lose money on the weekend. So if I look at this then, this means she needs to sell 20 necklaces to break even. And at 20 necklaces, she will have made $400. But also, that's how much she spent. So be careful when you think about that 400. It has two interpretations. It talks about both her cost and how much she made. So she's gained nothing, but she's lost nothing. Now, if you subtract the revenue function minus the cost function, what does this represent? So let's figure out what those were. So this function here, this is my revenue function. And then this function here, this is my cost function. So I'm supposed to take the revenue minus the cost. So let's do that. So if I take the revenue minus the cost, that's 20n minus the cost function, which was 300 plus 5n. So I've got to work this out. So this will come out to 15n minus 300. So what does this actually represent? This represents the amount of actual profit she might make. So if I look at R of 10, so this is the revenue with 10 plugged in, minus C of 10, what would this equal? So basically, what happens if I plug 10 into the two functions that I have? Well, let's see. If I take 20 times 10 minus this 300 plus 5 times 10. Well, let's work it out. This will equal 200 minus 300 plus 50. So this will ultimately equal 200 minus 350, so this equals negative 150. So I plug this into what I thought was the profit function. So what is this telling me? Well, this tells me at 10 necklaces, we already kind of knew this, right? We know she needs 20 necklaces to break even. So if she sells only 10 necklaces, then she will lose $150 on the weekend. So that would be the interpretation. Okay, and so that's all I wanted to talk about on this particular page. So we're going to switch gears on the next page, so I'll see you in the next video.